Bismillah ar-Rahman ar-Rahim. Alhamdulillah wa salatu ala Rasulullah. We are here, we will be studying soil mechanics. This is our course in this semester. This handout is already with you. Everybody has this course outline, which shows that our study is soil mechanics with these two numbers, whatever. Now, there is a course description, etc. I will not stop in everything, but mainly you'll be interested in knowing the distribution of grades for this course. We will have 2 midterms with 30% grading, homework and quizzes 10, and laboratory work for those who has laboratory. But in this semester this will be separated, so the change will be that 40 for the midterms, 2 midterms, 20 and 20, 10 for quizzes, etc., and 50 for the final exam. So there will be change here. The first midterm is known, its place, its time, okay, its date. After finishing these subjects, we will go to the midterm, the first midterm, and then this is the second midterm, you see. Then we go to the finals. This handout is already, you have it, and you can check it at home if you have any questions. Now we go back to the first page. As you see, the title is Soil Mechanics, soil mechanics. But when we go to the course outline, the textbook, as you see here, the textbook, I think it will come on the second page. Now the textbook is Principles of Geotechnical Engineering, you see? Principles of Geotechnical Engineering. Please, this international edition, we will not use it. We will use the 5th edition, okay? 5th edition. Okay? It's available in the university and other libraries. So, our title is Soil Mechanics, but at the same time, our textbook is Principles of Geotechnical Engineering. So, what's the difference? Is it soil mechanics or geotechnical engineering? Let us go to the page after first lecture. Okay. Now, the title, as you see, is it soil mechanics or geotechnical engineering? Is there any difference? Of course, there is a difference. Otherwise, we will not use 2 terms. Otherwise, it will be soil mechanics only or geotechnical engineering. There are differences, but there are minor differences. What you should know is geotechnical engineering is broader meaning. It has broader meaning than soil mechanics. Okay? So, this is a broader in its meaning. It may have some other aspects of soil mechanics, in addition to soil mechanics, okay? But in your mind, you will have soil mechanics or geotechnical engineering. They are almost the same, okay? So you may find books with the title Principles of Soil Mechanics, Introduction to Soil Mechanics, Soil Mechanics for Engineers, or you will find Principles of Geotechnical Engineering. You may find almost similar textbooks, almost similar articles there. There are little differences, but they are almost the same. Now, what is the definition of our subject, whether it was soil mechanics or geotechnical engineering? Of course, there are several definitions. I choose this one. The application of the principles of soils. See? Principles of soil. The application of principles of soil and engineering mechanics. So we have 2 things. We have principles of soil and engineering mechanics. to evaluation of the behavior of earth material. Okay? Now, from where we get principles of soil? This is from geology. And everybody of you already studied engineering geology, right? Okay. So this comes from engineering geology. And this one, engineering mechanics, it comes from strength of materials, which is based on statistics. You studied both, right? That's why nobody can study soil mechanics, this course, without having a prerequisite 2 courses, right? Geology and strength of materials, right? So, geology will give us principles of soil. Strength of materials will give us engineering mechanics. By combining both terms, the application of the principles of soil and engineering mechanics to evaluation the behavior of earth materials. This is our title. Okay? Now, why we study? Why we have to study this course? Well, we need you to pay for 4 credits. We need some money, you know. But also, in addition to that, we need other things. Let me explain what I mean. As engineers, when I saw a person and I asked who is he, they told me he is an engineer. In my mind, I understand that he's a person who construct or build, right? This is mainly the meaning. The first meaning comes to our mind, that he's constructing buildings, right? And all buildings, as you know, all buildings consist of 2 parts. This is superstructure above the earth, okay? And then we have substructures. Okay? Superstructure and substructure. Superstructure above earth, substructure below earth. Now, superstructures, by the time you end your studying in our college, in our department, by ending your 4th year in studying, you will be finishing courses like statics, strength of materials, then structure, 1, 2, etc., concrete, reinforced concrete, right? Design courses. You will be able to design everything called superstructure, because this building, whether it was a 1-floor building or multi-story building or a skyscraper or whatever, it composes of elements. These elements are columns, beams, slabs, walls, right? And you will study design of columns alone, design of beams alone, design of slabs, right? Design of walls, etc. So you will be able to design any structure because you will design elements of this structure. And of course, nowadays, nobody design alone. You have a teamwork, and you have, in addition to that, computer programs that correct if you have any mistake, right? So the chances that you will have problems here will be so minor, so little, okay? Nobody makes mistakes here, almost. Most problems come here, okay? 70 or more % of failures in buildings, in constructions, they are due to the substructure, misevaluating the substructure. So we have to give attention to this. The substructure, they are foundations. Foundations, the design of a foundation. Foundation is intermediate structure, which takes loads from above and sends it below, right? These buildings, all buildings rest on the earth. So the load comes from the walls, from the slabs, from the beams, to the columns, to the foundation, and from the foundation to the earth. So In order to design a good building, already I know how to design superstructure as I explained just earlier. I need to know what kind of foundation I have to use, how to design it. To know this, I have to know something about the earth here, right? So this is what we call, this is where we need geology. Geology gives us some ideas about the earth. But this geology, it's from geological point of view, it's more like comprehension, okay? It's not limited, it's description. We engineers like to have things in numbers, figures, equations, right? Symbols. We need to describe a huge amount of words in an equation, in a symbol, in a quantity, right? So that's why we need to change the geology that we took to engineering geology or to soil mechanics. So soil mechanics, it will give us the engineering aspect of geology, right? You have to understand that. By studying geology, then we have to study soil mechanics. That's what we are giving this semester. And after finishing soil mechanics, we go to foundation. You will study foundation engineering. By designing good foundation, you will not be able to design a good foundation unless you understood superstructure and soil mechanics and geology. You got it? You knew now the plan? Superstructure, you will end it by going to materials, to subjects like structure 1, structure 2, reinforced concrete, etc. Here we have to know geology, then based on that we have to study soil mechanics, then based on that we'll go to foundation. By designing good foundation, you'll be able to design whatever structure you will be faced. Okay? We go. What I already explained, it's A. Okay? Why we study soil mechanics? First, select proper foundation, substructure. You see? So, number one, select proper foundation. What kind of foundation I have to use for constructing this building? Do we have several foundations? Yes, of course. We have shallow foundations. We have deep foundations. And I have to choose which one is suitable for this building. Whether it is single, combined, cantilever, raft, strip, strap, whatever. These are all types of shallow foundations. I have to choose which one. Which one is suitable? I cannot choose that without being good in soil mechanics. Or may I have deep foundation? Then I have to use piles, sheet piles, braced cuts, whatever. You will know this when you study foundation engineering. Okay? So number one is to select proper foundation. Which foundation I have to use? Okay? Number two, I have to understand lateral earth pressure. You see, guys, every structure we build, load comes from above, downward, okay? From slabs, floors, right? Walls, comes to the columns, and then comes to the foundation. Loads are vertical, right? Loads are vertical. Loads are vertical. That's obvious. But sometimes we have to make cuts to make retaining wall. Then we have loads here from side. We call it lateral load. I have to design retaining structure. Retaining structure. Retaining structures are subjected to lateral loads, not vertical loads. Sometimes they are subjected to both. But mainly, retaining structures, they are subjected to lateral loads. Is it different than vertical load? Of course. Behavior is different, analysis is different, design is different. Okay? So, if I am to design a lateral retaining wall, sheet piles, braced cuts, dams. Suppose we have a dam. Okay? If we constructed a dam. It doesn't have any vertical pressure, except its weight, right? but it doesn't have any vertical pressure. It has lateral pressure. So behavior different. Behavior is different, analysis is different, then the design is different, right? So if I have to construct retaining wall, sheet piles, braced cuts, dams, basement walls, whatever, I have to understand what is lateral earth pressure, the theory of it, the analysis of it, how we deal with it, all of these things, right? Okay. So this is number 2. 3, design of offshore structures. Maybe we don't have this nowadays in our country, but you don't know where you will work. You don't know where you will work, and you don't know what will be in the future. But if you have docks, bridges, harbors, if you have lakes, if you have rivers, if you have sea, and you have to build on offshore, we call it, okay? You need to build special constructions, different than houses, different than buildings, okay? We have water, always, right? So how we deal with these problems, how we deal with these subjects. Also, we need soil mechanics to understand how we do this. Bridges, harbors, dams, docks, etc. Okay, now, you know that Palestine is an active earthquake area. You know that. You get it from geology, and you studied this in geology. We are subjected to thousands of earthquakes every day here in Palestine, but they are all of minor capacity, of small effect, almost no effect. We don't even feel them, right? But you know that Nablus was subjected to a major earthquake not long time ago. Almost every 90 years, of every 100 years, every century, we have a major earthquake. Last earthquake, which was 1927, although it was centered in Jericho, in the Dead Sea, but it's called Nablus earthquake. You know why? Because most damages was here. Most damages were in Nablus. Almost 1/3 of the city houses were destroyed. 250 people were killed. 500 houses were destroyed. Okay? And you know, you listen to news, right? And you know that we are expecting a major earthquake in the area, right? So, there is earthquake engineering. How I can construct a building that is safe against earthquakes. Can I do that? I give you an example. In 1906, almost a century ago, there was an earthquake in San Francisco. You know where is San Francisco? USA. On the Pacific, western coast of the United States. San Francisco. The city was almost destroyed completely. Completely destroyed. Okay? In 1992, okay, almost 90 years after that, a similar earthquake took place in San Francisco, same city. This time, San Francisco has several skyscrapers, high buildings. It has many bridges. So we expect the damages to be higher, right? Handful of people were killed. Handful. Several people were injured. Damages were minor. I think one highway was collapsed. How? How it happened? Because based on the first earthquake, earthquake engineering began to develop. And now we are able to build or to construct a high skyscraper with more than 100 stories, and this skyscraper can bear an earthquake of magnitude 7 in Richter. You know 7 out of 10, right? And no damages. Employee will come next day and continue their work safely. How we can do that? Earthquake engineering. which is based on understanding the behavior of Earth. We need soil mechanics here. Got it? Okay. Number 5. Sometimes we have special structures, different than all normal structures. Like what? Like I have a basement where I will put heavy machines, and these machines will work. Like in our laboratory, for example, mechanical department laboratory. We have very big machines, huge machines, and these machines will give vibration all the time, dynamic load. Okay, I have foundations to be subjected to a constant load, static load, but not dynamic load. Do they have to have a different kind or different foundations? Of course. So, these kind of things. Sometimes I have what we call it tankers, storage tankers. Those used for water, for oil, for wheat. Okay? Huge, cylindrical, like this, from above. Okay? Or they may be like this. They have different shapes, or they may be like this, for example. You know this kind of structure? This kind of structure in Seattle, for example. This is a restaurant above. Seattle, USA. So we sometimes have different structures than normal. They are different in shapes, they are different in height, they are different in load application, right? So they need special foundation. Normal foundation don't fit here. Normal foundation don't fit. So we need special foundations. So at this time, we need to understand how soil will react with dynamic load, not only with static load. All above, we were talking about almost about static loads, but here we talk about dynamic load. Last, soil improvement. You know, guys, that we need to deal sometimes with areas to construct, and this area, the soil is weak, and we have no choices. Our grandfathers in Nablus, they had choices. When they were to build a house, they went to an area where rocks are at the surface and bought this area and land and construct a house on it. But now we sometimes construct on an area where we have only fill, where we have very soft soil. But this is what I have, and I have to use it or lose it. So I have to use it. But the soil is very weak. Okay, if I cannot change the area, I can't change the properties of soil. Can I give it B12? Can I give it some medicine to make it very strong? Yes, this is soil improvement. We call it soil improvement, soil stabilization, soil reinforcement. How we can make a soil, the same soil, make it stronger, durable, make its properties, engineering properties, better. We need this for buildings. We need this for highways. We need this for railways. We need this for runways. We need this for bridges. We need this always. So these are all aspects why we study soil. Okay? No questions? These are at least good reasons for myself. I understand that these are good reasons for us to study soil mechanics. Okay. How? We had first the title, then why, and now we have to understand how. How we can study soil mechanics. How we will study soil mechanics. To solve any soil problem, we need 5 steps, as you see. The first step, collect qualitative information. Quality. What quality of soil I'm dealing with? Okay? This gives us idea about soil structure, texture, components, behavior. This is all what you studied in geology. That's why you have to study geology before. I suppose you know that. I'll make some brief review later, next lecture. This is why we study geology, because from geology we know kind of rocks, kind of soils, we know sedimentary rocks, we know metamorphic rocks, we know igneous rocks, right? We know that rocks composed of so and so and so. I'll explain this briefly next lecture. But all qualitative information, we bring this from geology, okay? Now, we add to this. We need quantitative information. Quantitative information. From where we get this? This we get it from statics and strength of materials, okay? And this is what we will concentrate on in our subject this semester, okay? You know what is E? Modulus of elasticity, right? Young's modulus, which is stress over strain, right? We know that. And so we know what is stress, what is strain, right? Okay. You know this what? What is this?
Dynamic.
This is we call Poisson's ratio. You hear the Poisson's ratio? Poisson's ratio is the ratio between lateral strain to axial strain. Okay? It's very, very important in soil. Poisson's ratio. Okay. You know gamma? What is gamma? Unit weight. We have to study it. Unit weight. Unit weight. Unit weight. Weight over volume. Okay? We need to know G. What is G? This is what we will study beginning from next lecture. We need to know W, E, N, S, C, phi. You know, all these things we'll get them from mechanics and from soil mechanics. Okay? So we got geology, we got mechanics, and then we need economy. That's why you have to study engineering economy, right? Because the engineering solution is an economical solution. You know, my grandfather or grandfather was able to construct a mosque, a building, right? Although he did not study in a civil engineering department or in any engineering department, right? By experience, he could. What's the difference between his solution, which was good, and my solution? Economy. That's why before, if you go to the ancient buildings, you will find walls like this, right? Width. And the distance between a wall and another is 2 meters. And the wall itself is 3 meters, right? So you know how much we wasted for that. Now, a very high skyscraper, we put columns, beams, floors, right? You'll see it like a skeleton. And then we cover it by stones, right? So the engineering solution is an economical solution. Everybody can solve a problem, but one can solve a problem with wasting 200 hours, $300, because time is money also, right? And another one can solve the same problem with less time, with less money, with less capacity, with more safety. So that's why we need to have economy. And that's why you have to study engineering economy. Soil is different than any other subject, even in civil engineering. You know, guys, civil engineering disciplines like statics, strength, structure, etc., all these kind of things, they all developed, almost reached the peak, the maximum. They settled. Now we don't have very new ideas in, like for example, in the distribution of stress and strain, or for example, how we draw a moment diagram, how we draw shear diagram, etc. They are fixed, they are stable. Okay? And that's why we have computer programs, softwares on every aspect of these disciplines, except soil mechanics. Soil mechanics began lately to develop, and still there is place for development. Okay? Soil mechanics, there is still place for development. We may have an idea tomorrow that overturn all our understanding of soil mechanics upside down. Don't be surprised. Soil mechanics still needs a lot of work. That's why in solving soil problem, we need a lot of past experience. Past experience is very important because we cannot cover all aspects of problems. It's like life's problem. You see? Do you have a textbook for life problem? No. There is no textbook that can contain all life's problem. So we need always past experience. We need experience. From where you get past experience? You are still students. Well, we will begin getting them from examples that we will solve, from problems that you will solve, from exams that you will face, okay? And from films that you may watch. And I advise you to see films related to engineering, like, you have some channels that present engineering problems. Do you know anything of that? National Geographic, Al Jazeera, Al Wathaiqiyya documentary, right? You have mega structures. You have some programs like that, which produce for you some examples, some problems that were solved in that area or in this. By watching a film of 1 hour, you will have a lot of information that you may not face in your life. You may be familiar, but after seeing some of these films, how this skyscraper of Dubai was built. There was a film about it. How this area of, the palm tree island in Dubai, the palm tree island, how it was built. Okay? You will have an idea about the Golden Gate, how it was built, bridge in the United States. The Hoover Dam, how it was built. The Twin Towers of Petronas in Malaysia, how it was built, right? So, past experience, this is a huge area where you can get a lot of information, a lot of important information that will shape your life, that will give you advantage over those who don't have this experience. So I advise you, I encourage you to learn a lot, to read a lot, to see a lot, to ask a lot. You as engineer, you must not go on a street watching several buildings in the time of constructions and don't look at them. You should look at every building. What happened here? Why they are doing like this? Stop, please. I'm getting down. And I go ask people there, engineers, what are you doing? Why you do like this? What is that? What is this? Etc. You have to question everything. You have to ask a lot of questions. They may tell you that you are troublemakers, but don't worry about that. By being troublemaker, you will be a good engineer. Okay? You need a past experience. Then we need a big plus. Bigger than this. Big plus. Engineering judgment. Engineering sense. You have to have a sense. You have to have a judgment. You see, guys, I can tell you. Do you like to live in this room? It's 5 meters long, 3 meters width, 5 centimeters height. Well, if I give this question to the computer, he will give me the volume of this room, and without any idea or without any question mark, without any surprise, he will not knock and say, wait a minute, this is not a room. Nobody can live here. Computer doesn't feel, right? Computer can defeat you when you play chess with it. Anybody plays chess with the computer? You will be defeated easily. Okay? You may be defeated easily. But the computer will not feel happy. He will not jump in the air saying, I won. Right? The computer doesn't have feeling until now. I don't know about the future. But you should have feeling. You should know that this answer, no, there is something wrong. It's impossible. Okay? You will have this sense. This sense comes from all before, right? From the experience, from all the information I will give you. We will study in this course. If I tell you, okay, we have an area with a sand deposit and we have a problem of swelling. And we found that the plasticity of this layer, sand layer, the plasticity is very high. You say, what? No, there should be something wrong. Either it's not sand, or the properties you are telling me are not correct, because it's impossible. Nonsense. Okay? Not possible, right? You should have this sense. And maybe this is the difference between a good engineer and a very good engineer. Okay? The difference is the sense. No. There is something wrong here. No, it doesn't work. It will not work. It's not right. It's impossible. Okay? You should have this kind of things in your mind. Okay? Now, so we will have these 5 things. We will compose, we will collect all of them, and then see how we can solve a soil problem. Okay? So, we have to collect qualitative information from geology. You studied 2 hours geology, right?
Yes.
It was 3 hours before, and now 2 hours. I don't believe that they are enough, but at least you know something. We'll review the most important thing. We have to know soil structure, soil types, soil texture. By the way, you studied texture in geology, right? Texture. You know types of texture. Okay. And then we have to collect all this information: unit weight, specific gravity, water content, void ratio, porosity, degree of saturation, modulus of elasticity, Poisson's ratio, cohesion, friction, stress, strain, and some others. I put here some examples. Okay, we'll deal with all of these things. And at the time, I'll tell you, okay, we have W 20% and degree of saturation 0. Oh, what are you saying here? There must be something wrong. Now you don't know that, right? But afterward, you will have the experience and the sense to know that there must be something wrong. How come? Okay? And then we have to add economy for that, and then we have to add past experience, which will begin with the homework that you will study. Okay? The good thing about our textbook, and I advise you to buy the 5th edition, and for those who were not here last lecture, which was not a lecture, it was just a meeting, I said that buying this book is very good for you, because it's a good textbook and a good reference for you as engineers later. Okay? And it is good for you for this course, and for some other courses later you may take, like advanced soil or advanced foundation. So you can buy Principles of Geotechnical Engineering 5th editions for DAS. Okay? Now, there in that book, what is good is it contains several examples, solved examples, and it has plenty of questions that need your effort to be solved. And there are, of course, answers at the end. Okay? And then we will have exams, and we may discuss some real-life problems related to engineering. And sometimes there are some news. I may ask you, did you hear what happened to so-and-so, what happened here, etc., what happened to that construction, etc., and we will discuss this, because by this you will get your experience. Okay? Then we will have the sense. Now this sense, I will insist on it in every lecture. You see? I will ask you, what do you mean? Or I will ask you, do you have any comment on this issue? Do you feel it's okay? Do you feel it's not okay? By the way, some of my questions in the exam even, it's explain. Explain why. You know, we don't have, in our studying life in the engineering, we don't have to insist a lot on how. We have to insist a lot on why. I know that in school, we insisted a lot on how. See? How many factors affect that issue? Oh, I knew them, 5. Write them, 5. Okay? It's not just read and memorize. We need to know how things change, how effect takes place. Why? Why? Why this thing happened? Why it happened here, it did not happen there? This brings us an idea about soil. What is unique about soil, as I told you, that it is not settled until now. So we have a lot of things to say. That's why we don't have a lot of softwares, by the way, computer softwares about the soils. I mean software, I mean common software for all the discipline. We have an idea. He brought an idea, you brought an idea, she brought an idea. You put a software, but this software is limited for A, B, C, and if I go to D, E, F, it doesn't work. You see? We have softwares. But still, until now, we have problems to say or to give attention to, etc. So, by this, we end the first lecture, and I hope that if you have any question, do you have any questions, guys? Anything to say? Now, what is good about this lecture? That you may have it even today at the computer. You see? So you may listen to it again, write your notes, whatever, okay, which you may not be able to write during the lecture. Okay? What is good is that you have it here in the computer. It may be today, maybe tomorrow. Thank you. Once you don't have questions, we'll see you 2 days after, right? Goodbye.